Hi, my name is Qingda Wang. Today I'm going to talk about designing workflows with IBM Spectrum LSF Process Manager 10.2. Process Manager is a workflow management software. It runs on top of LSF, so it enables the automation of workflows over a distributed computing infrastructure. It allows users to design, run, and manage computationally intensive business-critical workflows. Here's my demo environment. I have installed IBM Spectrum LSF Process Manager 10.2, Application Center 10.2, and LSF 10.1. I would like to point out they are also included in IBM Spectrum LSF Suite 10.2, HPC Edition, or Enterprise Edition. In fact, IBM Spectrum LSF Suite has recently won the HPC Wire 2017 Editor's Choice Award for the best HPC cluster solution or technology. I'm going to show you how to design a simple genomics analysis workflow. Before I start, I'd like to introduce two sample users. Gary is a bioinformatician. He's a flow designer that designs, runs, debugs, and manages workflows to be used by other biologists. And Mary is one of the biologists. She submits the flow that is designed by Gary, then monitors and analyzes the results from the workflow. So first I'm going to log in as Gary to create and publish a simple genomic analysis workflow. Then I'm going to log in as Mary to run the flow that is designed by Gary, monitors it, and then checks the result. In Application Center System and Settings, Gary has been assigned the Flow Designer role. This is necessary for him to create new flow definitions. So now let's log in as Gary. And let's create a new flow definition. I'll call this flow alignment. And now we are in the flow editor. Let's add the first job. This is an LSF job. And call it creating SAM. This job will do sequence alignment using BWA. I have used several variables like BWA bin sample name in this command. These are Process Manager user variables. They can be used to customize your flow so that each user can pass in their own value when they run the flow. For example, they can specify how many threads they want to use for the BWA algorithm, or they can provide their own sample name, which corresponds to different data FASTQ files. The user can provide these values when they run the flow, but Gary, as flow designer, can also set up default values for these variables in flow attributes. So they are defined as input variables. It's like the input parameters for your flow. So you can add these variables. Let's add BWA bin, which is the directory where the BWA binary is located. I have defined a few more input variables like threads, output directory, the binary location of SAM tools, sample name, and the project. The project does not have a default value. It needs the user to provide the value when they run the flow. Next, I define the working directory for this flow. This is the working directory that will be used by every job in the flow, unless the job defines its own working directory. I have used the environment variable home here so that the working directory will be located under each submission user's home. It's always a good idea to define standout and stand error files at the flow level. These will be the standout and stand error files for every job in the flow. In the file name, we have used the variables that represents the flow file name, and also %j, which represents the LSF job ID for the job. So we define these standout stand error files only once at the flow level, then each job will have its own file, and this file will be located under the working directory. Now let's run this job. And submit a test flow. So remember, we need to provide a project name. We can monitor the progress of the flow right inside the flow editor now. So if I refresh, now the job has finished. We can directly view the data for this job. This will take us to the working directory of the job, which is under home Sam to Ben, and Gary's home is scratch dev to Gary. And we can see the files are generated, like the error file, and you can tail it to see the output. And you can also view the history of this job, which shows how the variables are replaced, and the full bsub command. This is a bsub command, and you can see the current working directory, and also the sample name is replaced by the real value, and so on. And the job ran for about 2 minutes. The job has generated an output file located under output, which is the same file that has the sequence alignment. Next step, we are going to convert this same file to a more compact BAM format. I added another LSF job, convert SAM to BAM. It uses SAM tool to convert the sample.sam to sample.bam. Let's connect these two jobs. So the new job should only run after the first job has succeeded. Now we want to test the second job, and we don't want the first job to run again because it has already succeeded. To run just the second job, let's refresh the flow. We can select it and then just do rerun from here. So now the flow is run, and only the second job will be running. The green color indicates the job has started. And we can check the data for the second job. If we view data, we will be in the job working directory again, and there are output and error files generated. If we go into output, there is a BAM file being generated. Meanwhile, we can add another job. I just copied the definition from somewhere else. Let's call it sort, and we can connect it again, and if we refresh, the second job has finished. We can run just this job. So it has started running. As you can see, you can continue to work on your flow while some parts of the flow is still running. And in fact, you can always modify certain parts of the flow and then have the flexibility to rerun from anywhere in the flow. So just for demo purpose, let's change this file to sample2, this one as well. After we make the modification, we can choose to set a starting point here, and then say rerun test flow from the starting point, and then rerun the flow. And then the flow will start running from here. And we can verify the new file is being created. Output, and now we see sample2 is created. Now that we have made the flow work, Gary is ready to commit this flow to Process Manager server. And we can give it a version number. Now alignment shows up in the flow definition list with version 1.0. It's not published. To make it available for everyone to use, Gary asks the administrator to publish it. So administrator logs in and publish the definition. Now Mary logs in. She submits a flow from Gary's flow definition with her own sample and project. And she can monitor the data and the progress of her flow. Notice the working directory is under Mary's home. And we can see the files are being generated. She can also monitor the progress of her flow from flowchart. That's the end of my demo. To recap, in this video, I have shown you how a flow designer can use IBM Spectrum LSF Process Manager to design and test flow definition in a single web browser environment, get it approved and published by the administrator so that the flow can be used by end users. Thank you for watching.